I hope it's not broken. Yeah, that was kind of Rick and Morty opening. Um, what's up, guys? This is Embedded Adventure Day 24, where I am as a complete beginner, exploring the world of embedded systems, learning that thing, learning electronics, and I'm building a literal portal gun from Rick and Morty. And in previous series, so far, I made a circuit with a battery. Yeah, it looks pretty silly actually, but nevertheless, okay. Um, yeah, here it is, and I'm gonna just quickly remind you the whole idea of the project. I have like 3 modes. The first mode is just simple toggling button that opens and closes portal with sound effect. The second mode is capturing and storing Mortys like in the game of Pocket Mortys. And the third mode is actually multiplayer with several portal guns. So if you are interested, guys, keep watching. Today we're gonna finish the circuit. I hope I will get all the components delivered in time so I can assemble it. But let's continue. So in previous series we actually stopped when I just put this button here. Let me just make it a little bit larger. And I actually wonder what are those inputs outputs mean here. Yep, so I'm frequently using a ChatGPT, guys, so I hope you don't mind. I call it Vibe Embedded Systems. Yep. No, my magical button is broken. Finally, I'm in Germany. Thank you. Okay. Okay, so first of all, I just gonna want to ask ChatGPT like about the button because I'm not really I don't really know the button inputs and outputs. So yeah, can you also help and list out inputs and outputs that button, that simple push button has? Well, I can actually Google it. Well, like I have like the what is it? It's S2 button. Probably Google it. Not a big deal. So S2 button. Scuff Gaming. Holy shit. Oh my gosh, Scuff Gaming. Okay. So push button 2 pin. 4 pin. Yeah. Internally how it works. Pins on the same side are already connected. Pressing the button connects left side to right side. Oh, that's how it works. So use 1 pin from each side, not 2 from the same side. Okay. Interesting, actually. With 4 pins. So you mean like I need to just connect like 1 from one side and 1 from the other side? So I don't really need to... That's strange actually, but okay. We probably can actually use it. By the way, let's also check the ESP32 pinout. I know, guys, I know that it's actually not ESP32, it's just a similar board, but actually there is no ESP32 here in FreeZync. I probably can import it, but not a big deal. It's just more like it's more like the just drawing to understand how to assemble all that thing. Yep. Basically, so not a big deal, but wait, what? Oh, just desperately searching for ESP32. No, not a big deal. Okay. I want to just find the ESP32 pin out. Like I heard that. I usually check this on Random Nerd Tutorial. They have a pretty good picture of it. As far as I remember, like an introduction. No, they had it. They had it. Yeah, here we go. The amazing picture. So probably input only. So basically a button is just a simple digital signal, yep, so basically any GPIO that supports like the just basic logical signal can participate. It doesn't need like DAC or ADC or any shit like that. So we can basically actually connect it to, I don't know, like any of those. We actually don't need like ADCs here or DACs either, so I guess not a big deal, but okay. So probably we can connect it. Huh. By the way, are there any tutorials about the buttons? Like, I'm just a little bit curious, like, are there any button tutorials? By the way, is that recording? Yep, correctly. No, yeah, yes, okay. Right. You know what, let's just simply the ESP32 push. Yeah, push button example. Just want to see how it should work. Oh yeah, I like privacy. I like privacy, guys. Damn, I like privacy. No. 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 Oh, hell no. Save settings next. Just want to see how it usually connects. A PCB mount button usually has 4 pins that are internally connected in pairs. Okay. We only need to use 2 of the 4 pins which are not in the same connected pair. Okay. Currently there are 4 ways to do wiring with the button. Okay. Because of symmetry, these 4 ways becomes 2 ways. The rest of this tutorial will use 2 pins. Pin A and pin B. Okay. One button's pin is connected to a digital input pin of ESP32. The other pin is connected to the voltage. Oh, okay. So basically, like imagine we connect a button, for example, to the voltage, and currently, like the ESP32 will have, for example, we'll connect it something like that, and get the fuck out of here, breadboard. Yep. Let's just imagine we connect it somehow to the pin, and basically what it means, we should actually take the voltage from here. Like let's imagine that. Wait a second. Yeah, let's imagine that we took this voltage supply from the voltage DC booster that we actually managed to understand in the previous series. So we can take voltage from here. No? Can we? like say like this. Just simply no, like how? Just want to connect that thing here. Can I? Nope. Yeah, that's connected. That's connected. Basically it, I guess. Well, it seems okay. Like in terms of like internal logic, we just need to measure the different voltage level on the pin. Like if it used to have ground, then it should have voltage. If it used to have voltage, it should have ground. Something like that. If I understand it right. Standard state, the relation between the state of the input pin and the button's pressing state depends on how we connect the button with the ESP32 and the setting of the ESP32's pin. There are two ways to use a button with ESP32. One button's pin is connected to a digital input pin of ESP32, the other pin is connected to voltage. A pull-down resistor must be used. A pull-down resistor must be used if the button is pressed. The state of ESP32's pin is high. Otherwise, the state of ESP pin is low. One button's pin is connected to a digital input pin of ESP32, the other pin is connected to GND. Okay. A pull-up resistor must be used if the button is pressed. By the way, what is a pull-up resistor? I just pull up resistor. Okay. Just to set to ensure an input pin defaults to a defined high logical state when no signal is actively driving it. That's how it looks like. Okay, I got it. So basically, if button is not closed, then we get the voltage here. If button is closed, then we get GND here. Well, it seems logical, at least. Damn, I have to learn electronics. I came to this conclusion literally every video, like, I have to learn some electronics. Currently I understand only what I read from ChatGPT here. I'm so stupid, guys. So stupid. But okay, we continue. It's anyway, maybe I should read some books about it. Check the course. Yeah, and pull-down resistor is basically the same thing, but with GND, I guess. Well, yeah, so if we connected the button to voltage, then we also have a resistor to GND. Yep. Okay. So probably we need to install a pull-down resistor here, because we connected it for the voltage. Yeah, we connected it for the voltage. So we have to install the pull-down resistor, but how do we need it? Neither pull-down nor pull-up resistors use the state of the input pin as random between high or low. This is called floating input problem. But wait a second, there is actually no resistor here. Just look, like they connect the ground to this side. Yeah, okay. They connect this side directly to GPIO. They don't use any resistors. Like, I don't know, maybe it uses it internally. Perhaps. But okay. That's actually interesting. does 4-pin push button includes pull up or pull down resistor? Probably not. Then why why they are connecting it directly? Huh. Okay, let's assume that's how that's somehow handled internally. You know, maybe it's handled in the pin itself. In the input pin. Maybe. By the way, they use fritzing as well. That's cool. Yep. Okay. So then we did nothing wrong, absolutely. We should only specify in the code that we want our resistor, our GPIO to act like, in our case, pull down resistor. Yep. So it should implement pull down logic. So if no signal goes here, it's by default ground. Yeah. Okay, button is connected. Finally, we should connect some LEDs. LED. Yeah, just a basic LED. Nothing interesting actually here. Because, well, you know, the interesting thing is how will I place them? There's no like a single LEDs. I want to use addressable LEDs actually, but I don't know how they are used properly. I want to place them somewhere here, so one here, one here, one here, but this probably will be quite weak LED, quite weak glowing. I will try, but probably I will have to switch to the, you know, I don't know how it's called, but let me just Google it. Addressable LEDs. One moment, guys. Close, but I guess more like this, more like a sequence of them. But I have only these ones. They're actually here in the box. Yep. Okay. Are there any like that? Yep, here it is. But it actually has like 6 legs. It's like a mad LED. You know, there is a like a regular one, but that's actually boring. I want to use colored one. Yeah, with 4 legs, I guess. That one is strange, but 4-legged LED is pretty cool. It's pretty cool. I just want to Google how it really works. So, 4-legged LED. Yeah. Just wanna. Oh, so it get the RGB values in those 3, and it get the ground here. Interesting. That's interesting. Actually, they are all equivalent length, but I will assume that that one is... Oh, yeah, that one is red. That one is probably ground. Yep, common cathode. Green and blue. Okay. So... I actually need to connect it somehow to... I want the colors to be configurable. I want them to really be configurable. But I want them, you know, to be configurable together. So I want like 3 LEDs. Yep, so this thing has like 3 printed parts for LEDs, 3 printed sections. So I want to have like 3 LEDs, basically. Yep. 1, 2, and 3. Let's put it like this. Yep. And let's connect them to, I know, these digital. Yeah, basically these. I guess I will use the lat-c controller with PWM function, so I can actually dim them. I can change the brightness. I guess there will be a lot of fun things that I can do with this glow, that I will probably record. But at least I need to assemble it. At least I need to assemble it. Probably I will prototype it on the breadboard, but I need at least some elements for it. Yep. Okay, so one moment, I need to oh, yep. So let's connect them. Basically, let's assume that will be like the red one. Yep. Red one. Well, this one is red as well. I'm just basically doing the same stuff. Not really, I guess we should do something like that. Break it here. Here we go. Okay. Damn, it's actually not that accurate as I thought. But okay. Is it connected, by the way? Or no? By the way, I probably can't really connect them like in this way. Probably it's not really... It's possible on the breadboard, but... in reality, I guess it's not that possible. That of a possible, yeah. Well, only if I solder them. Yep. Only if I solder them. By the way, what about soldering? You probably didn't really notice, but I actually got delivered a good flux and a good solder. So I guess I should make a second short video where I finally will freakingly solder the LED to the resistor. Yeah. I guess that's actually a good idea. It's actually a good idea. Probably I will do that after recording that video. Yeah. So wait for a new short video. Wait for a new short video, guys. Maybe it's already uploaded. I don't know where I will upload that one. Okay, so if they are not connected directly, and by the way, guys, I messed up. I need a resistor actually. I need a freaking resistor. Yep. How could I forget about resistor? Let's assume that's an appropriate resistor. I have a bunch of them, so I don't really care which I use here in schema. It's just the matter of fact that it's here. Yep. So let's connect. This one will be the red for that LED. Yep. Oh, it's actually not connected. What the fuck? How the fuck it's not connecting? Why the fuck it's not connecting, guys? Oh, you know, guys, I actually like to work in Fritzen because, you know, it's so intuitive. I have like all these elements here, but I just hate the connection system. It's just so broken. I don't know, for some reason. Like, why can't I connect that thing to a resistor? Why? What's wrong with that? What's wrong with this connection? It's not broken in some, like... Oh, finally we fucking connected that shit. Okay, yep. Fair enough, we connected. We earned the prize. The prize is a portal gun from Rick and Morty, yeah. I don't know, guys, I hope I will just be able to travel across dimensions to actually, I don't know, meet myself in the future. I'm interested what will be with this channel, with my journey. That's actually interesting, guys. Yeah. I hope it's actually possible, but yeah. Okay, how can I connect that shit? That? No. It's finally connected. So yeah, I probably got that fucking Fritzen. Sorry guys for many bad words I use here. I'm just a little bit mad about Fritzen. It's like a little bit broken, but okay. Yeah, maybe I just drank a lot of coffee here. No, this actually won't connect. Okay, a little bit more patience here. If I go here and draw it here. Oh, now it's connected. Okay. So let's assume we have connected it. Yep. More here. By the way, you probably guys will ask me like, why do you care so much about schema? I just want to have less troubles when I will assemble it. Probably there will be much more troubles when I will assemble it than, well, it's better to have some troubles here than to like assemble it intuitively and not have your circuit that won't work. And that wouldn't be even my fault. That will be like, how the fuck that happened? Yo. FreeZync is broken, guys. FreeZync is completely broken. Damn. Yo, I connected that thing here. Or no. I connected. Yep, I have successfully connected that thing. Okay, what if I want to connect that thing here as well? Oh, I can't do that. Why can't I really do that like through this connection? Like maybe consider it as separate wires, probably. Probably, yeah. Okay, you know, there is a good hacky thing. Can go to schematic mode and connect them here. Wait a second. Which one am I working with? I'm working with this one. This one is LED 3. So where is an LED 3? Just wanna, okay, what if I selected here, LED 3 and here? LED 3, where are you? I guess this one? No, it's LED 4. Oh, I got it. I got it. Yeah, so the problem is, yeah, like I need a LED 2. Yeah, they actually have internally 3 LEDs, but where is it? Where is it? Oh, that makes more sense. Yeah. So here is the LED 3 that I actually want to connect. Okay. Just simply. Oh. Yeah, I want to just move the, yeah, the, like, you know, soldier mask here, or how it's called. And actually I want to connect the red pin of it to the R2. Red pin to the R2. Where is R2? R2 is one moment. Oh, by the way, here it is. Here it is. A little bit broken as well. But let's connect it. Let's connect this to this. Let's go to the... Yeah, finally. So, and now probably I can connect that finally. Yes! Finally, I got how FreeSync freaking works. So you first have to connect it in schematic mode, and then you have to connect it in breadboard mode. Let's continue. Okay. I have never thought that will be so happy to do something in massive FreeSync program actually. Yeah. Are they actually connected or no? You know, let's make all the connections like correctly, but like, let's check. Okay, these connections are more or less okay. Yeah, but I can see that they are blue. These ones are probably not okay. Okay, let's remove that shit. That shit as well. So strange. Okay. Let's go to schematic mode and connect. So R3 is here, so R3 is for LED 2. Where is LED 2? LED 2, where are you? Here it is. So basically we want to connect that thing to that thing. It's pretty scary to actually do that in schematic mode, but here everything is just fine. We connected that shit. We finally can make a good connection. So I make it just like I just, by the way, interestingly, no, does no, fuck it, let's go create new chat. I'm working in FreeSync. Does it have some kind of DRC rules to check whether the circuit is connected properly, or to emulate the work of a circuit? Very limited checking. It does not really do full DRC. Yeah, by the way, guys, if you don't know what DRC is, like DRC rules. DRC is design rule check, so basically it checks like whether your circuit will work or will not. Yeah. So basically it will tell us whether I get the I don't know, shortage or anything like that. Okay, what it can do: connectivity checking. It knows which pins are connected by wires or PCB traces. It can highlight unconnected nets on the PCB, basic errors. Okay. Cannot simulate circuits at all. But it actually can check the connectivity, which actually pretty useful. So okay, let's continue. R2 to LED 3. Yep. Where is R2? Yeah, I see. I can see it well. The only problem is that the LED 3. Where is the LED 4? Oh, so the LED 4 is here. Okay. I just currently need only the LED 3. Yep. So we need to connect the LED3 to the R2. Yep, okay. And finally we need to connect, yeah, by the way, let's draw the connection line. We need to connect the R1 to LED4. R1. Where's, oh, here we go. R1 to LED4. Perfect. That's basically how it's done. Yeah, but it's a little bit boring. I do consider it boring, but it's needed to actually not have like much problems during the assemble, which I hope I will be able to record or at least try to assemble that circuit alone tomorrow. Yeah, many components that I've ordered are coming tomorrow. Probably only speakers are coming the day after tomorrow. So yeah, I hope they will be delivered in time, and I will create this like until the like holiday ends. Yep. Because then I will have like exams and all that stuff, which I pretty hate actually. LED4 to R4. LED4 to R4. Oh, here we go. By the way, guys, let me know in the comments, would you like me to throw a stream like till the end of the like this holidays? I guess that's an interesting idea actually. I'll probably consider doing a stream. I don't guarantee like how long will it be, but I guess that's interesting experience. I would like to try, but it's up to you guys. So yeah, let me know in the comments. So LED4 to R5. LED4 to R5. Holy moly. There's the R5 LED4. Yep. Okay. Damn, R6 to LED3. Yeah, but we'll finish it right now. Wait, what? Like R6 to LED3. Where is R6? Where? Oh, here we go, guys. They're chilling out there. So again, LED3 to R6 and then R7, yep. So R6 goes here. Yep, and R7 goes here. Then that's like the worst schematics ever. Probably, yep. But that's actually fun. I don't know, that's a pretty calm process, you know. Like some kind of meditation. You're just simply wiring the schema up and imagining how it will work in reality. Yeah. R8, LED2, and R9. Yep, let's connect them quickly. LED2. Yep, LED2 is up to the moon. Let's connect it. Okay, and R9. R9. Finally, we've almost done it. We've almost done it. I haven't said like we have done it. because we also need to wire that thing up. I guess, like, which one of this? R1. Yep, R1. Let's go to schematic. By the way, can I? No. Interestingly, the Control tab works here, but the Control Shift tab does not work here. Not very convenient, but I don't give a damn. R4 to the to that thing. Wire 147. Let's check like the R1. Where's R1? Oh my gosh. Oh, here R1 is. So we should connect the D3 to all that R4, R5. Well, we probably can do it here to like to make it easier. Oh no, actually we should only connect red ones here. No, actually not. Okay, let's connect the R2 then. R2, where are you? Okay. The moment of truth. Can I simply just, like, you know, connect it like the other way? Yeah, like that. Finally. Finally a more convenient way to connect the resistors. By the way, the button is not really good. It's not placed like very good here. Probably should move it a little bit. Oh. So that's how you do it. Alright. You know what? We're gonna, just to make it a little bit more beautiful. We all like beautiful schemas. Where's this button? S2. Where is S2 here? S1. Here's the S2. So, let's connect the first one to the voltage, to the output of voltage regulator. No, actually to the switch. Yeah. That's what we need. I need to connect the switch output from here up to the any like input here. Not really. Not really, I guess. Guess I messed something up. So if I delete it, I'll get the oh, so I messed up. Yep, I messed up a little bit. That's more strange because I thought like that side is already connected, and yeah, it's indeed connected, so we get this connection here. Wire 264. Oh, let's delete it. Then, oh yeah, okay, here we go. So let's connect that thing here to the first one. Okay, we can actually do that. We can actually connect it this way. Let it be like that. Yep. It's a little bit messy here, but we actually can, you know, we actually can move that button here. You know, let's pretend that we haven't connected yet. Yeah, that's what I wanted. That's what I wanted actually. I wanted to connect it directly to switch. Yep. And here I will tie this to some pin. Well, the ESP32 actually have plenty of pins on the side with the voltage input, voltage output, so not a big deal. Finally connected here. So let's connect the R3 to the same thing that R2 has. R2 has D3, yep. Let's just tie this up. Okay, and just literally go here. Perfect. Now I like it. Now I like it. Okay. Damn, I almost fucked up my LED here. Okay. And now let's basically connect all those pins like pretty much in the same way. I don't really know, like it does really differs. It does really differ. So probably maybe I will edit this and I will cut this out so you guys won't really see all that process here, like R4, R6 to the same shit as R4. Damn, my bail words actually. R6 where? No, that is R7, that is R6. Okay, and R8. R8 to the same thing. Damn, I'm now actually doing that quicker. Yep. But again, that's so meditative. That's so meditative. The perfect thing to do in the evening, guys. Perfect thing to do in the, well, actually not evening. It's like half past. It's like 10:30 p.m. 10:32. Yep. Okay. It's like almost night time. Okay, R7. R7. Actually, guys, you know, yesterday I haven't slept like for, I don't know, till like 4 a.m. I guess. Yeah, that was a horrible feeling. I was doing some actually very destructive things, like actually don't want to actually tell you what, like a lot of things that goes like through my mind, but I actually just want to stay consistent on that journey. That's all I want actually in this new year, so I just actually hope that 2026 will bring me consistency in my life. That I will never fall off, or if I fall off, then I will get up quickly and just continue to make videos for that channel and continue to do that cool project. And by the way, the electric diagram is ready. That's no. Not ready. It's not ready. Where is the ground? Where is the fucking ground? Wait, what? Wire 121? You know, that's strange, actually. That's actually strange. If I choose that wire here, will it be here? No. I actually only need to connect all of them to the ground, but the ground is usually somewhere here. Oh, by the way, it's in the same place as the ESP3. No, actually, well, almost. It's like In ESP32, this one is 3 volts 3, and this one is GND. Here is this GND. Okay. Not a big deal. Not a big deal. Yeah, let's finally connect that thing, and I'll finish the video, probably. Where? Oh, here we go. Okay. Oh my gosh. Just simply connect it. Yep, so guys, yesterday I stayed up late, so I've done almost nothing productive, like, but for real guys, if you want to achieve something, I guess the only way is consistency. I haven't achieved anything because I wasn't consistent with what I wanted. But I hope that consistency will bring like the success. And it really does. It really does. One moment. How the fuck? How they are connected actually? Yo, they are somehow directly connected. No, no, no. I actually don't need that connection. Delete. Can I delete it? I just want to delete it. Yo, I want to delete that connection. I don't need it. I don't need that connection. Well, maybe if I connect them directly, then delete it. No, actually, no. The schematic, in schematic, they are actually do the controls out. Yeah, actually, that's how it's supposed to be. They should be connected to the ground correctly. So I should connect that one to the ground as well. Oh, so that's how it works. I actually haven't imagined like, well, I guess that's pretty much the same if they have this like the same ground. Probably it's not a big deal. Like as you can see, they have like the same ground. Oh, actually that one is failed. Okay, you know what? Actually, no. I want to connect here. Just seems more accurate, and just connect the LED 2 to the ground as well. Okay. So let's just tie this up. Finally, guys, I made an electronic schema for a very extremely basic mode of portal gun. Currently, it is a very basic, extremely basic version. I should add here a screen, I should add here a speaker, I should add here Pocket Mortis logic. Yeah. But that is basically the most working example of the portal gun that I will implement. Of course, I will upgrade it, add a screen, add some things, but it's like an MVP here. Yep, so we did it. We did it, guys. Okay. Whew. By the way, how much am I recording? 55 minutes, holy shit. Okay guys, so if you enjoyed this video, hit the like button, subscribe to my amazing channel. Yeah. That was Embedded Adventure Day 24, and I made an electronic schema for a portal gun. That's super cool. In next series, I hope I will assemble it. Yeah, I will assemble the portal gun schema. And in next series, I guess I will code it. Or other ways around, I don't know. Actually, it depends how quickly my components for that project got delivered, but okay. Thanks for watching, guys. See you soon. stay consistent. Bye.